Okay, so today we're going to cover Chapter 8, Section 2. And today what we're going to do is prove triangles are similar by angle. Now, keep in mind that this shortcut is only for triangles. Yesterday we talked about all polygons in general when they were similar, but today this shortcut only applies for triangles. So let's see what the angle similarity theorem is. And this states that if two angles of one triangle are congruent to two angles of a second triangle, then the two triangles are similar. Notice when we did the shortcuts for triangle congruencies, we needed to find three pieces. This one, we're only required to find two angle pairs that are congruent. Because remember, with similar figures, their angles are congruent. It's the sides that are proportional. And again, this shortcut only applies to triangles. Next slide is an application of this shortcut. Now, sometimes the figures that are given are not obvious, and we may have to reach back to prior knowledge in order to find two angles that are congruent. Now, a lot of times when the triangles are sitting on top of each other, then they usually share an angle. So, for example, in example 1a, the two triangles they're referring to are this little one that's at the top, and then they're asking us to compare that to the larger one, which is the whole thing. Now, notice the angle that's up at the tippy top here is the same angle in both the red and the blue triangle. So far I've accomplished in finding one angle pair that's congruent. Now I need to find a second pair. Now, notice the only given here were that I had parallel lines. So I knew that this line is parallel to this, and I can use this side as a transversal, making this angle congruent to this angle because they're corresponding. So if you were writing a proof, this would be your reason. So now I've marked this angle congruent to this angle. I have two angle pairs that are congruent. So I can say, yes, these are similar, and the reason is the angle similarity theorem. Now in example B, it's obvious, it's already marked for you. You can see that this angle is congruent to this one, and this one is congruent to this. So I do have two angles that are marked as congruent, two angle pairs. So this one is also yes. And if they ask you for a reason, it would be the angle similarity postulate. Or theorem, sorry. This book calls it a theorem. Other books call this a postulate, but our book refers to it as a theorem. Example C. Again, all I have marked originally as given is an angle and a side. Now, if I were asked to prove these congruent, I could do that reflexive side and say side, and both angles are congruent. All congruent triangles are similar, but in order to prove that these are similar by that shortcut, I need to come up with another angle pair. Let's look at this triangle as a whole and not split it up at first. So as a whole, this is actually an isosceles triangle. And I can use my base angles theorem and state that these two angles at the bottom are congruent. And now that I've put that in there, now I can show that this triangle on this side is similar to this triangle on this side. Again, by angle. Yes.
So if you were to split up the two triangles and have the transversal, the side that they both share, could you say those two angles were also congruent?
the angles at the bottom of that median, well, we don't know that they're congruent yet. We don't know that they're perfectly right or that it splits it equally. Once I show these guys, because I don't have any parallel lines here, I just have congruent sides. You follow? Are you talking about this angle down here?
Yeah, so even though the transversal is congruent on both sides, the angle still can't be congruent necessarily?
Well, no, because separately, that doesn't help me. Only as a whole do those congruent sides help me.
Okay.
So individually pulling the triangle apart versus like the blue versus the black, that doesn't tell me anything about that. Now, as soon as you show that two angle pairs are congruent, you could use your third angles theorem and say that that last one is congruent.
Okay.
But without showing the other base angles congruent first, you couldn't. All right, and then the last one, you may think that these are not similar, but they are. And the two triangles they're referring to are going to be this one right here. And then the other one is this one. Notice they both have an angle that's marked as it's congruent to each other. And then notice both the red and the yellow share this angle. So these are also congruent by angle. So this one is also yes. If it helps you to pull the yellow one out, it would have had this one marked and then this one. And even though they're not facing the same way, then I have the red one that's like this, and this was the black one that they both had in common, and then this red one. And again, you have two angle pairs that have the same markings, so this one is also similar. Same shape, just different sizes.
Miss Corey, I'm really confused with C.
All right, so what you need to do is, let's go back to C. Let me redraw it. And I had this marked, and I had these marked up at the top. So if I don't look at this dividing thing, if I just treat this all by itself and just look at that, I have an isosceles triangle here. And I know by the base angles theorem that these base angles are congruent. So now if I go back to my original picture, even though it's divided, these angles down here are congruent to each other. Now what I'm doing is thinking of this as being its own triangle and this as being its own triangle. And because I have two angles that are marked with congruency marks, I can say that these are similar triangles because of AA. They're actually congruent triangles. All congruent triangles are similar. They can be exactly the same size and shape and still be similar. Is that better?
Yes, that makes more sense, thank you.
You're welcome. Okay.
Miss Corey,
Yes.
can you go over D one more time?
B?
B.
B as in boy? This one?
D as in dog.
D as in dog. Got it. Okay. So let's go ahead and again, we could pull them apart. Let me erase, start from scratch. So I have this one here. So I can draw that one. And it has this marked up here. And then I have this little one over here. Maybe I should do that one in blue so it shows up a little bit better. And then it's marked here with a congruency mark. So right now my two triangles have an angle that's marked as congruent. And maybe it might be more helpful if I add letters. So like this is A, B, C. So this would be A, B, C. And then I could put like a D and an E here. So A, D, E. And then notice that this angle A here, 1, 2, is the same A that's in both of them. So the first angle was given to me, and then the other angle that's congruent is the same angle that's in both when you pull them apart. So because I can show two angle pairs that are congruent, this is similar by angle, angle. That better? Again, let's pull them apart. Maybe it'll help too if I add letters to this. So let me put an A, a B, a C, a D, and an E. So I'm going to refer to this top one. Let me go ahead and redraw it over here. And I'm going to put A, B, C, put a 3, put a 5. And that's all I know so far on this one. And then the larger one, I'm going to call this one ADE. It's going to be in blue. ADE. Now for this one, to get the length of AD, I'm going to add 3 plus 1, and it's 4. But then to get the side of AE, I'm going to put this as 5 plus X. Now, in order to make sure that they're similar, so I can set up a proportion for their side, again, I had parallel markings here. So if these are parallel, then this is my transversal, and I can say that this angle is congruent to this angle. So bottom angle D is congruent to angle B of the red. And then for the second angle, I can just show this angle up at the top, angle A. It's the same in both. So these are similar, so now I can set up my proportions. So again, I'm going to take the two sides that are going straight up and down, and I can show that this one and this one match. So I'm going to put 3 over 4. And then I'm going to match this hypotenuse here, this longer side, saying 5 over 5 plus X. And now I'm going to solve the proportion. I'm going to multiply diagonally. So I'm going to multiply 3 times the 5 plus X. And then I'll do this diagonal. 4 times 5 and get 20. I'm going to distribute. I'm going to move my like terms together, so I'm going to move the 15 to the other side. And I get 3x equals 5. Divide by 3. X is equal to 5 over 3, which simplifies to 1 2/3. Pretty good on example 2. Let's try example 3. So let's pull them apart again. It's sometimes easier to see. So I'm going to refer to the small blue one here. Let me go ahead and redraw that. So D, E, B, this is a 3, this is a 4, this is a Y. And then I have the larger one, I'll outline this one in red. And then I have this triangle. I have 8. This side here, I'm going to add the 3 plus 4, and it has a side length of 7. And then this side over here, I'm going to list it as x plus 3. Now again, if I need to write a similarity statement, I need to find the angles that match. So again, you can see angle B is the same. So angle B is congruent to angle B. So notice how they've already started me. That's going to be my middle letter. But now I've got parallel lines again. So this is parallel to this. So again, you can use your transversal, either this one, and say this angle is congruent here. So C is congruent to D. And that would be enough. You could have also drawn a transversal on this side, and then you would have shown that A is congruent to E. So this will help me with my statement. So you can see A matches with E, so I'm going to write that first. Then B matches with B, and then C matches with D. So that's your similarity statement. The order matters there. Now that I have the similarity statement, when I go to write my statement, let me jump down to C and do the statement of proportionality. Let's match the sides. So C, they already started it for us. So they're showing us that this EB or BE right here is matching with BA. And then next what I can do is state that, how about this one? The DB is going to match with CB. And then I can do the third side, this side right here, where the 8 and the Y are. And again, all of the tops of my fraction are all coming from the smaller triangle. So I could do ED, and then I would do AC. So that's the statement of proportionality. Now when I go to do my proportions to find X and Y, this might be kind of helpful. So what I'll do is, I need to look for the two sides that have numbers. So out of my answer in C, I'm going to look for the fraction that has all the numbers. And that's going to be the BC and the DB. So these two, you see how they both have numbers? So what I can do here is my scale factor is 7 over 4. If I'm using the given statement from the big to the little. If they would have reversed it and said little to big, then you would say 4 to 7. So I can go ahead and use my 7 over 4 to find Y. And the side that matches with Y is the 8. So since I went from big to little, when I solve my proportion, I need to go from big to little here. And now I'm going to cross multiply. So 7 times Y, 4 times 8, divide by 7, and Y equals, 7 goes into 32 4 times, with 4 left over. So the length of Y is 4 4/7. I wouldn't make this a decimal because it probably goes forever, so that's why I'm making mixed numbers. And for X, I'm going to use the same scale factor, 7 over 4, but the two things I'm going to use in X, I'm going to be using the X plus 3, and it goes with the 3. So in my fraction here, X plus 3 over 3. And now I'm going to cross multiply. 4 times X plus 3 is equal to 7 times 3, which is 21. 4X plus 12. Move the 12. 4X equals 9. Divide by 4. And X equals 2 1/4. This one you could have made a decimal because it's 0.25. But again, yes.
Doesn't that matter how you set up the fraction as long as it's like
Yeah, it doesn't matter. Yep. So if you would have preferred to do 4 over 7 and then 3 over x plus 3, that works also. Absolutely. And then the last one is a nice simple proof.
Miss Corey,
Yes.
for letter C, the numbers are like not in alphabetical order, and I'm used to putting in alphabetical order, so if I switch the letters around, would it matter?
No, it doesn't matter. Like on the green one here, if you put BD and BC, you could do that. And then here you could do DE, but then you have to reverse and make this CA. So one of these would have been in mixed up alphabetical order.
So the angles have to match as well?
Yes.
Okay.
Technically it's a segment, but try to stay consistent and go from the same angle to the same angle. Everybody good on example 3? Let's try example 4. Here's our proof. Let's set it up. A statement column and a reason column. So my first statement is my given. And my picture is already labeled with the given. Now remember, our only shortcut we've learned for proving triangles congruent is angle, angle. So I need to come up with 2 angle pairs that are congruent in my figure. Now, because I have parallel lines here, I can use AB as a transversal. And then I can state that angle A is congruent to angle B. And that reason is these are alternate interior angles. And I can name it with one letter because there's only one angle sitting there. And this reason, try to write it neater than I did earlier, alternate interior angles theorem. Now, I could also draw another transversal this way and also say that C is congruent to D. And then I could just add this to the same reason. And now I have enough information to prove my triangle's congruent. AOC is similar to BOD, and that reason is angle, angle. Now, if you would have preferred to just show one of the alternate interior, and if you wanted to instead show the vertical angles are congruent, that could have been a different step. So if you only wanted to show one out of these and then add in an extra step, you would name this with 3 letters. You could say AOC is congruent to BOD, and that reason would be the vertical angles theorem. So this could have been another angle pair that you found in the picture that was also congruent. You can choose. So that is it for section 8.2. You do have a homework assignment that is posted. And now what we'll do is I'll start going over the homework for 8.1.